Well, hi, good morning. Thanks so much for joining me here in my shop on March 3rd, a day where a big storm is coming. A big snowstorm is coming. Maybe the biggest one of the season is coming tonight. So, okay, but that doesn't bother me right now. What bothers me a lot is this radio. This radio is bothering me a lot because nothing seems to be easy with it. I'm getting a few emails from some of you. Why aren't you doing this? Why didn't you take that approach? Well, so let me explain just a bit. But first, what I intend to do today is the RF alignment on this radio. Excuse me. So what I'm trying, a lot of questions around why not just replace this thing? Just replace this coil. Maybe you've done this kind of thing before. Maybe you've replaced one of these coils on a radio and you've had great success and you're not concerned about it. I have the donor radio down there at my feet, just waiting with its IF transform. It's just waiting. So what I am trying to do is two things. One, have the radio in some kind of operating condition, even if it's weak, so I could do other work on it and be able to test the radio to see if I've made a mistake. And all this capacitor replacement I did and other stuff, that's what was going on. I wanted to make sure that there was a state that the radio, operating state the radio was in, that I could do some work and then check that operating state again. It doesn't have to be good, just has to be, something goes in the antenna and comes out the speaker. Then I feel much more secure in doing work. I know myself. I make mistakes. I don't know how I do it, but somehow I manage to do it. I make lots of mistakes when I'm doing this work. Some of those mistakes can be extremely difficult to find. So that's why, shotgun replacement of parts is dangerous. Replace everything, turn it on, it doesn't work. Oh my God, there's 3 mistakes in it and other stuff and a broken part you didn't even know about and who knows what. So I'm trying to avoid that. So the purpose of the bypass primarily is to make the radio work to some degree so I can do other things to it, clear off any other issues that might be in the radio, and then come back to the tough one, which is this coil. I'm almost there now. I have to do 2 things. One is the RF alignment, and part of that is going to be the process of getting the local oscillator into the proper range, because I have a capacitor I installed here which is probably too small to do the job, and it's causing the local oscillator to be way out of band. I'm pretty sure, I believe that's the case. So that's parcel of that. Once I have that completed, then I can play the radio, find out how efficient the bypass is. I don't expect the bypass to be very efficient. In fact, it already works better than I would have imagined. On the broadcast band, the radio is actually working quite normally. So, kind of surprising to me, but there you go. Shortwave band's all messed up because of a silly problem with the switch here, which I didn't pick up on soon enough, and a failed capacitor and an incorrect or a not so well thought out replacement that I put in there. So when the time comes to deal with this coil, if I decide the bypass is just not getting the radio there, then what I will do is I will remove this from the radio. I may not even remove it from the radio. I will attempt to find the actual break on the wire on this coil. Almost impossible to do. This lead wire starts underneath the coil, underneath here. There's no pulling it out or pulling it off the top. And the other wire, well, I can't really see it, but I'm going to guess it's on the top. But it may not be. It may also come in the bottom of the coil. What are you going to do? So I don't want to face those things. I don't want to attempt a replacement with a radio that's full of other problems. I won't know what I'm doing. I won't have any way to sense what I'm doing. And since often what I'm doing is senseless anyway, it's a sad attempt at humor there. So, okay, RF alignment. And if you hear frustration in my voice, I am frustrated by this project. I'm telling myself over and over, this is the glory. This is the glory. This is where I'll get dragged through stuff I've never even thought about before, forced to deal with issues I've never dealt with before. Going to come out a stronger, better repair guy, even if I'm bruised and battered a little bit along the way. I keep telling myself that. Yes. Yeah, and I do have pressure on this. I have a garage full of radios waiting to be fixed. So, yeah, I got like a dozen radios out there that I could be working on instead of this one. Oh well. Yeah, and just to top it off, the cabinet's in bad shape too, although I think I can just glue it all back together again. But, this is not a glorious radio here by any means. Okay, so I think I can probably pull off the RF alignment on the broadcast band with the radio as it is. To do the shortwave bands, I must solve the problem of the incorrect sized capacitor here, or so I believe this is the problem, and get the local oscillator into the range where the trimmer can locate the local oscillator properly. So there's a certain range to the trimmer, and right now the local oscillator is way out of that range. So it doesn't matter how much trimming I do, I'll never get the local oscillator all the way up to where it needs to go. Figuring out what to do about this capacitor would be a little bit challenging. I don't really know what... Well, actually, the schematic does say what the proper size is, so... Okay, I won't get into that yet, because we're going to do alignment on the broadcast band. And I got to find some instructions. I mean, don't I have any instructions? I don't think I have instructions for this. I better find some. Let's spend a little time on the alignment information here. This page is covering two radios, a 683 at the top and a 684. This is my model down here that I'm fighting with. I've read through this already. This is very well written. I'm not going to read the whole thing to you, but this came from Radio Museum. You could download it too if you wanted to, really. But why? Here we are. So I think one of the interesting things that's talked about in here is the dummy antenna. And I think I've mentioned before, I don't like that term, dummy antenna. It's not an antenna at all. It's components inserted in the signal path coming from, say, a signal generator designed to make the radio think it's hooked up to an antenna. So you can align it as if it's hooked up to an antenna when it really isn't. So what do they say? The term dummy antenna means the device which must be connected between the high test oscillator output terminal and the point of connection of the receiver in order to obtain ideal alignment. Another thing is this rock through, which I've had a lot of difficulty trying to do this procedure, but you really don't need to do this anymore because through use of an SDR I can determine exactly where the local oscillator is sitting, and from there this hunt down thing with the rock through process isn't really necessary. On some tuning ranges, it is found that more than one peak may be secured if the trimmer is adjusted over a wide enough range. Now, you're using the word trimmer here. Where this occurs, it should be noted that oscillator circuits should be aligned using the peak, which occurs at the lower capacity or inductance setting of the trimmer. In some cases, when people use the word trimmer, they are referring to a capacitor only, but not in this case. This engineer did a little different. So that's the rule. Let's read the rule again. It should be noted oscillator circuits should be aligned using the peak, which occurs at the lower capacity or inductance setting of the trimmer, at the lower end. But wait, except for the 49 meter band spread circuit is an exception to this. It's just the opposite. On RF, or first detector trimmers, the peak occurring with the larger capacity setting of the trimmer should be used. What? So they give a rule here, and then they immediately tell you, no, don't follow the rule. It's specific to what you're doing. But it's important to note these two peak things, because while you're doing the adjustment, if you're only seeing one peak, that means you haven't really pushed the adjustment far enough to find the second peak, so you don't know where it is, you don't know where you are in the scheme of things. Or something's wrong with the radio and you can't achieve the second peak. And they're not, well, they might be more specific in the actual instructions on how to do the alignment. This is for setting up push buttons. It's a mechanical push button arrangement, so we don't have to worry too much about that. This is the alignment instructions. Unfortunately, it's just written on the diagram here, and the reproduction isn't all that good. So up here they talk about the dummy antenna. They say link open, input onto, looks like AA1, I think that says. For operations 1 and 2, you use a 0.1 microfarad condenser. And for operations, for all the rest of the alignment operations, you use a 200 picofarad capacitor, much smaller capacitor. So I did the IF alignment steps 1 and 2 with the signal generator connected directly to the radio without this. Would it make a difference? Not enough to matter at this point. Everything is just being done rough and first time through, so getting everything exactly right, peaking everything up 100% is not necessary. This is just to get the radio into a state where I can make a judgment about how well it will work, or where deficiencies might still be occurring. So that's the objective. I'm not trying to get it ready to go, go home. Right? It is home. I own this one. So step 1 and step 2, I've done those. So we don't need to worry about step 1. Step 2, we just need to think about, whoops, where am I going? I'm way too far over here. I'm lost. Here we are. So we're doing these ones, 3, 4, 5, and 6. Just doing 3 and 4, in fact, I think. Maybe we'll see. 200 picofarad condenser. It's a very small capacitor. Your signal generator output, mine anyway, whoops, oh my gosh, what's all that? It's very low impedance, of course. That's what you want with a supply. And the low impedance will throw off the radio if you just hook it straight up. So here we have operation 3, operation 4. It's the trimmers right on the capacitor. First one is the broadcast oscillator, done at 1500 kilocycles. And then the trimmer, same place, 1500 kilocycles. Hertz, as we would say now. Kilohertz. And where is number 5? Is this one? What does it say? Adjust by, oh my gosh, adjust by bending up or, I guess, down on a loop around the broadcast oscillator coil at 600 megacycles. Okay, that's something totally different from what I've ever done before. Adjust by bending up on something. Wow. Okay, well, when we get to that, we'll have to look into what they're doing there. That's, I guess they avoided installing another capacitor and saved 14 cents a radio or something. Perform operations in numerical order as indicated in brackets. Apply oscillator input to antenna terminal. Connect oscillator high terminal to the grid of the something or other tube, blah blah blah, 2 meg resistor in series at the grid end as grid end of cable. I think this is if you're going to use your oscilloscope to do an alignment. They mentioned it's not necessary, but if you wanted to do it, apparently there's instructions here on how to do it. That's probably that right there. Okay, so we kind of looked this whole thing over. Good enough for now. 19 meter, 31 meter, 70 meter, what? 70 meter, what's that? So, some kind of, I don't know what that's supposed to say. Something, meter, trimmer, 9500, so you can bet it's 31 meter or something. Okay, yeah, I don't think there's anything else here to be concerned about. One thing is, look, the IF can's designed for 460. I shot it, I did them at 455. Not a consequence. And just one more thing. How is it that I move the slug in the defective coil and it caused an alignment effect in the radio? I didn't really talk about this, but that blew my head off, because it seems as if the coil is good. So I don't know what to make of that. But let's not deal with that. We'll get around to that when I eventually approach that coil. Whoops. This is what we want to do. We want to do this one, and then this one, 1500. Okay, I got it. So the first step in any alignment on a radio like this is to make sure the pointer's in the right place on the string. Now, if nobody's ever done anything to it, probably the pointer is on the right spot on the string. For me to know that here, so I don't think there's any marks for me to follow. I think it mentioned in the instructions there's a spot on the dial face that you try to line the pointer up with when it's closed, something like this. I can't do it, so I'm not going to worry about it. So I got my signal generator running at 1500. There it is there. So we're just going to have to assume at this point we got 1500 on here. No doubt I'll be doing this alignment at least once more in the life of this, or the death of this radio. Okay, so let's turn down the strength here. Turn up the volume. Okay, that sounds pretty satisfactory. You can see the AVC here, it's quite low. I'm on the 15 volt scale, so there's not much AVC action. So we're ready to align. Tune it in, because you might say, well, that's counterproductive. You're cheating. Because I don't have a dial scale to set it to 15. So now what can I possibly do? No use changing the oscillator position, because I just cheated the radio into this spot. Let's just go ahead and do the antenna side. Oh, you know what? I don't have the dummy. I don't have the dummy in, dummy. Okay, I gotta put in the dummy capacitor here. I gotta dig one up. Just for interest's sake, this is what the real official dummy antenna looks like, although I don't like the word dummy antenna. This is the device you hook up to the hot line on your oscillator and to the antenna. So a couple capacitors, that's a coil and a resistor. What are you doing there? I was going to demonstrate something that, of course, didn't work when I went to demonstrate it. So I'll put this on the antenna here. Let's get the changing sound. I encountered this yesterday. Wait a minute. Oh yeah. There's no antenna hooked up. No, I've got it hooked up right to the terminals in the back. So we're going to want to open the link. Turn this down. Turn it down. We don't need to listen to that. Just got my wires mixed up here a bit. I've got my wires mixed up. Going through life with mixed up wires. Okay, and the little capacitors here. 200 picofarad capacitor. I'm going to follow their instructions. Now I'm going to change this for crying out loud. For crying out loud. Another phrase I learned from my mother. Which I must have heard that 20 times a day. I also heard this from my mother all the time. Can't you sit still? No. I couldn't. I still can't really sit still. Okay, out with the link. And let it get grounded. This is the A1 right here. Take the hot lead here and we'll just put it here. Now, so radio got quieter. Where'd the signal go? I turned it up full. That's interesting. That's a little interesting. That's not interesting at all. Did I not hook it up to the right place? Now, normally you have the link closed when you're doing a single input. Maybe this is supposed to, no. Okay, I gotta read those instructions a little closer because I think something's going wrong already. Ah, a little closer observation, and I grounded out the terminal here by accident with the link. Wasn't paying attention. Let's turn it down. There we are. Now what do we hear? We hear nothing, but I retuned this. I'm looking at the AVC voltage. It's pretty good. No, it isn't. No, it isn't. No, it's not that good. What's good mean? 1.5 volt scale. There's just a little bit of AVC. The meter will go down to here between if there's no signal. But that's not very much AVC voltage, but that's what we want. But unfortunately, the signal strength coming from the signal generator, and I better check the calibration here before I say anything more. So that's a moderate signal in terms of an antenna. This would be a moderate antenna signal. That's good. That's all good. Now, I can now make the adjustment that I've been leading up to all this time. Skipping there. I see this going way up over here. Didn't sound any louder to me. 5 volt scale now. Opening this way up. Opened up right open there. I'm going even further. I'm just trying to get a grip on that. Right here. It's just about at the peak and it's wide open there. That's not very good. Seemed to me we got a boost. Let's just tune the signal generator a little bit to make sure we're on the money. Sure. Okay, the dial may not be accurate, but the rate is very sensitive. Is there any other? Is there another alignment objective here? Let me just check. So we didn't do 3, not worth doing. That was the oscillator. We did 4. Look for 5. 5 says adjust by spacing up or something on something loop around the broadcast oscillator port at 600. Adjust by bending up on the broadcast. Okay. What are they talking about here? Go around this way. There we go again. What was that? What is that? Is that a cold soda drink in here? Well, I don't know what that is that happened to us so often, but it does. Okay. So so these are the two shortwave RF coils, and the one we're interested in is this one. Now there's no adjustment for that, except some crazy wire. Crazy! It's a crazy wire. You have to find the crazy wire in there. Oh, I think I see it. I can see the crazy wire. Let's switch cameras here. Get a closer look. Turn this down because it's blasting right up into the microphone, so sorry about that. You probably had trouble hearing me for a while. Here we go. Crazy wire. Crazy wire. You see a crazy wire. There it is. It's crazy. Oh my gosh. Well, what are you supposed to do with that? Wow. So is that a loop that's grounded at both ends, and then you just move it around to affect the coil? Well, that's a good question. Let's look at the schematic. What does it show about that on the schematic? Good question. This is commonly called a gimmick. So if you're looking at it on, I think it's this coil. It's this one. There it is, right here. Oscillator coil. There it is. The gimmick. So you're supposed to move this around. It's on the oscillator coil. That's going to change the oscillator frequency, isn't it? But this is I don't quite get that. So we did 3, 4, maybe 5. But just by bending up on something or other, loop around the broadcast coil at 600. Oh, we're at the other end. We're at 600. But again, I can't really do this because I don't know where 600 is on the dial without putting this radio back in its cabinet. You get it back in the cabinet, you can't possibly bend this wire. How are you supposed to do this? How are you supposed to do this? In fact, there's even a metal base on this radio. Let me switch back to the radio here. There's a big metal base that goes on this radio. I don't even have that in place. The base has a couple holes in it. But the holes give access to the two IF transformers. They don't give access to... It's a quandary. But what do I do at this point? Since it's affecting the oscillator, there's no real, I want to say that tuning benefit. There is, in the sense that you need the oscillator to track properly, because when you tune the radio, you have two things tracking together. You have the RF and you have the IF. And as you tune, this is bad to do this in front of a camera because of parallax stuff. You want them to stay together. And what can happen is you got them together at one end of the band, but as you go up to the other end, one leads the other or whatever. So the RF side of it is kind of fixed in a sense, a little bit fixed. The oscillator side of it, you can fool with both ends, and this can shift it like this a little bit. You can stretch it this way, that way, or compress it, and do all these weird changes with the linearity, I shouldn't even use that word, the way the radio works. We'll leave it at that. I can't do anything about this right now. The broadcast band was working good. The real issue is the short wave. What in heaven's name is doing that? Well, I should be able to move something else and achieve the same weird. I got a break in one of my leads? No, it won't do it, of course. What am I not seeing? Well, I think it's going to remain a mystery still. Way over here. Maybe not. This is just a capacitor here. Well, that remains a really weird thing. I don't know what's going on. Something tugging on something? Okay, that threw me right off. What was I going to do? I was going to play the radio and just make sure it works. And then we'll look at the more difficult part here. It may seem like I'm not achieving much because to some degree I'm not achieving much here. In fact, I got to stop. I got to flip an antenna switch. I got to drink coffee. I got to do something. No antenna. Something is doing that. So what I think we could have lots of volume here. Wow. I'm a good antenna. Okay, let's put the real antenna on and just see if that stops. It does, but I don't want it. There must be something. Something's going on. Ground? No, ground first. This is probably pounding away in the microphone, I'm afraid, because my speaker's here, and it's aimed right at the microphone you're listening with. So I apologize. I'm hearing things differently here. I'm in my own world, and I apologize if audio problems have occurred. We have the antenna connected, and we have the signal generator disconnected. The volume is barely turned up now, so we're doing good on the AM band. Watch this. We're getting lots of. This is a 15-volt scale now. We're getting lots of ABC action. Excellent. There's that French station. Come on. Now, I did not have the ground on for the antenna right now. No French station. I have the link open. I don't think that's right. close the link. Not using the loop antenna. Link is closed. The antenna is connected just behind on the terminal itself. Didn't seem to make any difference at all. Where did that come from? Oh, French. In Canada, we have two national languages, French and English. And there was a time, I'm sure it's still going on today, but where a decision was made to introduce French into English-speaking schools. I'm in Ontario, I'm in an English-speaking province. I began being taught French in grade 6. So grade 6, 7, and 8, we had the same French teacher, and what he would do is he would travel from school to school and class to class, covering the town. I lived in a town of about 3,500 people. He had a couple of schools, and he would travel around from school to school, class to class. So some point in the day, he would come into our room and teach us French. The problem here is the man was from Jamaica. So, the result of that is a small town in southern Ontario where people spoke French like this. Voici un stylo. I'm dead serious. The whole town had a Jamaican accent when it tried to speak French. There was no French going on, by the way, because it was an English town. So unfortunately, French was limited to the classroom, and when that was over, it was over. 6, 7, 8, into high school, 9, 10, and partway through grade 11, and I can't speak French, I can't read French. It's terrible. I feel so sorry about that. But that's what happened to me, and I think it happened to almost every student in Ontario when it was time to learn French. And today, not to be political, but in Quebec, English is essentially outlawed. So in English Canada, we're kind of dragged through French classes unsuccessfully. And I don't know what happens today, but that was back when I was in school. Meanwhile, in Quebec, you dare not speak English. Well, that's not quite true. Okay, enough of that. Where's the French station? So I'm going to put the ground on. One thing about living in Canada is because we have this split, I shouldn't even say split, that's not the right word. Because we have two main cultural groups, even that's not even a fair statement at all, the English and the French. We have had to develop in a way where we're tolerant. It's historically, there was some of that going on. If you go way back, hundreds of years, it was a real fight going on. But so we've had to become tolerant. We've had to develop tolerance in our society. And the result is that tolerance spills over into everything else. And that's one of the great things about being Canadian. You may not like what the other guy's saying, but you can tolerate it. Tolerant people. I don't know if that's true or not. Who knows where truth is? Come on, French station. Beautiful.
Puis si moi je vous en parle aujourd'hui, c'est parce que fondamentalement derrière tout ça, ce sont des personnes qui sont malades, qui parlent, qui donnent des entrevues, notamment à Radio-Canada, puis qui vivent vraiment des situations très très difficiles, puis donc ils jugent vraiment que la province ne fait pas assez pour les rassurer.
I think I heard him say Radio-Canada. I don't even know what station this is. I don't even know where it is. Because it's in French. And I learned French as I explained to you. Parlez-vous français? Un peu. That's about it. Okay. The other thing, too, is, of course, we're not being taught French as it's spoken in Canada. We're being taught Parisian French as it's spoken in France. How stupid is that? That's just so stupid. Because the only French people I'd ever talk to are people from Quebec. And I can't talk to them. Yeah. Well, there we are. That's good. I like that. Let me get something else. Right there. Not bad, except for the interference there. And that seems to be specific to my house and in particular my shop here. Okay. I may call it quits here today. I don't know how much I've done. So I'm going to stop for a while, see how much time I put in here. Don't want to make videos that are 16 hours long. So, yeah, we're going to stop briefly here. I'm kind of wandering around in circles anyway. Yeah, I think I'm going to call it quits here at this point. It's a good spot to stop. The next step is to sort out the local oscillator range problem and the capacitor in the back. That's going to take some time. It's a whole thing in itself. So I think I'm going to stop here for today. I got to get out to the stores before the snow flies. And we're probably going to be holed up here in our house for a couple days after the snow comes. So. Okay, thanks a lot for watching. Sorry about me talking about non-radio stuff, but I'm a human being. Sometimes stuff comes out of my mouth. See you on the next video.